So for those of you who are not here, it might be a good idea to listen. So it says that we have a 0 of 1, we have a 0 of 3, and we have a 0 of 2, which is multiplicity 2, which means it occurs twice. So that means x equals 1, x equals 3, x equals 2, and x equals 2. So now how do we start to unravel this? What do we do? Subtract 1, and I get 0. What do I subtract here? And I get
0.
Subtract,
2.
and I get
0.
subtract,
2.
and I get
0.
So now this means the next stage of the game is we say f of x is equal to some unknown constant times x minus 1 times x minus 3 times x minus 2 times x minus 2. Want me to let you in on a little secret?
Yeah.
Okay. The ordered pair was negative 1, 5. If I have no roots and if I have no i's, I substitute now to find my a, because I find that to be a whole lot easier. So a is going to equal negative 1 minus 1 times negative 1 minus 3 times negative 1 minus 2 times negative 1 minus 2. So 5 is equal to a times negative 2 times negative 4 times negative 3 times negative 3. You with me? Yes, Paige. That ordered pair came from here. F of negative 1 equals 5. Came from the problem. All right, so that's going to be 8 times 9 is 72. So 5 equals 72a. What is a? Do you see how much easier it is at that stage of the game? Okay. However, if you have roots, there's not much you can do. So I'm going to rewrite this. There is a video online. I've got a lot to teach today.
Okay. Sorry.
All right. Now, what do we do from here? This is where all the work is. What do we do? Anybody? Oh, I'm going to keep 5 over 72. So we're going to multiply these and those. So this is going to be x squared minus 3x minus 1x plus 3. Multiplying these, you get x squared minus 2x minus 2x plus 4. So now you've got f of x is equal to 5 over 72. All right. How about x squared minus 4x plus 3 and x squared minus 4x plus 4? What do you think so far? So we have one last multiplication to do. Now, as I do this, I'm going to go vertically. X to the 4th. I'm going to distribute the x squared, so that's going to be minus 4x cubed. And I'm going to distribute that and get 4x squared. Now, when I do the next line and I do negative 4 times x squared, that's going to be negative 4x cubed. So I'm going to line it up over under my x cubes. Negative 4x times negative 4x is plus 16x squared. And then negative 4x times 4 is negative 16. Now I'm going to distribute my 3. So I'm going to get 3x squared. Oh, it should be. Thank you. So now we're going to distribute this, which is negative 12x. And then we're going to distribute that, and we're going to get a positive 12. So now as I add vertically, which I think is easier, but you do it the way you want to do it, you're going to have x to the 4th minus 8x cubed, 20 plus 23x squared minus 28x plus 12.
That's it.
Yeah, that's it. Any other? I leave it there. Any other questions?
That's all you taught.
Yes, when we have roots and we have imaginary numbers, there's additional roots you get from that.
Okay, but that's roots.
Okay, listen to my notes online. No other questions? All right, so let's go to Descartes' rule of signs that I should have done initially. Okay, I don't know what this is. Rational numbers are numbers that can be written in the form of a over b, where a and b are integers, like 2/3, 5/9, 4 over 1. Irrational numbers are rational numbers that aren't rational. Pi, e. If you have another example, 0.3 repeating, 0.67, those are rational. If I have a number that does not repeat, then it's considered irrational. Real numbers are everything. Complex numbers can be written in the form of a plus bi, where a is the real part, bi is the imaginary part. And you already knew this, right? All right, because we already did that. Now, zeros. I think this is the test that I have used every single one of these words. I may ask you to find the zeros on one question. I may ask you to find the roots on the next question. I may ask you to find the solutions on the fourth. And I may ask you to find the x-intercepts on the fifth. They are all the what? Same thing. Okay. This, I don't know if this is movable or not. Let me see. No. What if I, no. So, hello? Coming. And the 2x plus 1. So this is going to be rational. And this is going to be rational. Okay, what is this going to produce? Irrational. What will this produce? Irrational. Okay, what will this produce? Complex. And what will this produce? Complex. All right. So we have here the zeros, rational, irrational, complex. All right, Descartes' rule of signs is really easy. It says let f of x be a polynomial with real coefficients. The number of positive real zeros of f is going to either be the same as the number of sign changes from positive to negative of f of x, or less than the number of sign changes by a positive even integer. In other words, you keep subtracting 2. F of x has only one variation in sign, and it has exactly one positive real zero. These are not the complex ones. These are the real ones. Okay? Now, to get the negative real zeros, then you have to substitute negative x first. And then you're going to count the number of sign changes after that. And then it's either going to be equal to that or less than that by a positive even integer, which means you subtract by 2. If there's only one variation, then it has exactly one positive real zero. So those are online. Most of you have probably already figured this out. So let's look at this. We're going to start with the positive ones. So we're looking for sign changes. Was there a sign change from 3 to negative 2? Yes. Was there a sign change from negative 2 to negative 1? Negative 1 to positive 7? Yes. Positive 7 to positive 7? Oh, what happened to them? Positive 7 to negative. So there are 3, or take away 2. What do you get? 1 positive real roots. Now the problem is I lost my problem. There we go. All right, so that's how we do the positive ones. To do the negative, we have to substitute. So we're going to say 3 negative x to the 7th minus 2 negative x to the 5th. I have to see this work on a test. Minus negative x to the 4th plus 7 negative x squared plus negative x minus 3. So odd power, there's an odd number of negatives, which means this is negative x to the 7th. Odd power of negatives means this is negative times negative is positive. Even number of negatives means that will end up positive, so the sign doesn't change. Even number of negatives means that's going to be x squared, so that's going to be plus 7x squared minus x minus 3. Now, going back, is there a sign change? Yes. 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 Is there a sign change? No. So there are 4 real, let's see, there are either 4 or, what should I say, 4 or 2 or 0 negative real roots. You subtract until you get to a negative number, and we can't have negative roots. Yes?
What are you talking about?
That means that the zeros, if you solve this equation, you either have 4 negative answers, 2 negative answers, or no negative answers. This says you're going to have either 3 positive or 1 positive. Always subtract 2. So you start here and you subtract 2. Yes, Paige.
How is the minus negative x to the 4th?
Okay, because that is going to become x to the 4th. And then there's the negative. Does that make sense? Okay. Yes?
What if there's, like, you're not assigned?
If there's not a sign change here, then there's 0 positive real roots. Then you guys substitute in your negative and then see from there. Now, this may help us where we need to go today, and trust me, we need as much help as we can get. Okay, so we're going to go into the rational roots theorem. Okay, you did this in Algebra 2, and I'm sure you loved it. It's tedious. Rational root or zero theorem. If a polynomial f of x has integer coefficients, that means no fractions like 2/3, and p over q, where p over q is reduced to lowest terms, is a rational zero of f, then p must be a factor of the constant term, and q is a factor of the leading coefficient. The constant term is the term with no variables. That's a B. The leading coefficient is the coefficient of the term, that didn't spell right, of the term with the highest degree. Remember? We talked about leading coefficients before. So what they're going to do on one homework, and this wasn't a very well, these problems were kind of skipped by many. They gave you a 0 and they asked you to solve the polynomial. Now we're not going to give you a 0 and you have to solve the polynomial. Okay, so in this polynomial right here, what is the constant term? It is negative 15. And what is the leading coefficient? 5. So if I were going to set up P over Q, I would be setting it up as negative 15 over 5. Okay? So we're going to list all possible zeros. So what you do is you find your P and you find your Q. What is P? Constant term. 6. What is Q? 2. Now you list 2. Okay, so now you're going to list all possible factors of 6. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now what are all the factors of 2? 1 and 2. Now I don't have to do plus and minus down here because it is taken care of up there. Now how do I get all possible zeros? We take all possible combinations. So the first thing I'm going to do is plus or minus 1 over 1, plus or minus 1 over 2. Have I done all possible fractions 1 over 1, 1 over 2 with 1?
Yeah.
So now what are you going to do?
2.
Plus or minus 2 over 1,
2 over
2 over 2. And what is 2 over 2?
1.
That's a repeat. So now I'm going to start with 3. Plus or minus
3 over 1.
or 3 over 2, and then plus or minus,
3 over 3. With 1.
wait a minute, there's no 3 down here.
Oh, no, 5.
6 over,
6 over 1.
and then plus or minus 6 over, but we already have a 3. So what are all the possible zeros? Plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 3, plus or minus 3/2, plus or minus 6. Do you remember doing this in Algebra 2?
No.
You don't remember this? Do you remember this? This was pre-calc 2?
Yeah, it was in training.
Okay, so let's do another one, and then we're going to put it together.
I don't know what.
Okay, what is, again, it's the constant term. What's P? What's Q? And it doesn't really matter about the positive or negative in this, because when we do the factors, we're going to choose both positive and negative of the 3. And what's the only factor of 1? So what are the only possible factors here? 1 over 1, which is the same thing as plus or minus 1 and plus or minus 3. Any questions on how to find all, pardon? Right, this is a test question where you just list all the possible zeros, okay? I need to know that you know how to do that. If I do, then it's going to take you super long time. No. Okay, so now, here we go. Finding zeros of a polynomial function. This is where we're going to use Descartes' rule of signs. And this will tell you how many positive and negative, because this could shorten your guess and check. Find all possible rational roots using the rational root theorem. That's where we did plus or minus the P over Q. This is the P over Q stuff. P over Q deal. Now, using the synthetic division and what you learned from Descartes' rule of signs, eeny, meeny, miny, mo, you are going to test different possible roots until one produces a remainder of what? 0. When you get 0 as a remainder, then write the polynomial. At that point, you're going to write the quadratic or the polynomial that follows, and let's see, as 2 factors based on the results in step 3. If one of the factors has degree 3, you have to repeat step 2 and step 3 until you find the remaining factors.
Can you go back over that again, please?
Let me do one, it makes more sense. Here we go. And until you get lucky. Once you find one of them, if it's a quadratic, go factor. If it's a cubic, you got to go do another one. Yeah, so watch. Here we go. This is not factorable by grouping. Okay? Not factorable by grouping. So the first thing I'm going to look at is Descartes' rule of signs. So we have no change, we have one change. We have no change, correct? So I know that there is one positive real root. Okay? Now, if I do f of negative x, that's going to give me negative x cubed. Isn't that weird how my drawing kind of messes up the thing? All right, plus 2x squared plus 5x minus 6. So I substituted in the negative x. Negative x squared is positive x, so that's why that negative times negative is positive. One change, no change, one change, which means you have 2 negative real roots. Yeah. Or 0 negative real roots. So let's do the P over Q deal. What is P? 6. What is Q? 1. What are all the factors of 6?
Wait, why is it not second?
Because I'm going to do plus or minus 1. So doesn't matter. Plus or minus 1? Plus or minus? Plus or minus? Plus or minus? 4 doesn't go, 5 doesn't go, 6. What's my denominator? 1. So now, we do all of these numbers over that denominator, which gives me what? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. This is when the synthetic substitution comes into play. we've got coefficient 1, we've got coefficient 2. Make sure that you pick the original and not the f of negative x. We've got negative 5, and we've got negative 6. Now, do you see this little number over here, right there? This number right here is going to either be positive negative 1, positive negative 2, positive negative 3, or positive negative 6. So now let's look at this. You have to eeny, meeny, miny, moe this now. Which one of these do you want to try? But look at your Descartes rules of signs. If you pick a positive, you have 1 in 4 chance. Actually, 1 in 8. If you pick a negative, you have 2 in 8 chances, correct? You with me? There are two of the ones that work are negative, one's positive. So do you want to start with negative numbers or positive numbers? You with me on this? Do you understand what I'm saying about this? Okay. You have 4 positives to choose from. Oh, I haven't gone any further. You have 4 negatives to choose from. This is telling you that one answer is going to be a positive. And 2, you're going to have 2 negative real roots, or possibly 0. They could be imaginary. If I want to pick a number, I'm going to choose a negative because there's more negative possibilities that work than positive. So Mike said negative 2. Did you check it already?
No.
So we're going to bring down our 1. We get negative 2. What does this give us? 0. Negative 2 times 0 is 0. Negative 2 times negative 5 is 10. I have a remainder of 4. What have I learned?
It's not
Negative 2 does not work. Okay, so I've got 1, 2, negative 5, negative 6. What are we going to choose next? Negative 1. So I've got negative 1. So we bring down. We have negative 1, which is 1. Negative 1, which is negative 6. What happens? Positive 6, 0. This is good. What does this mean? That means that we have that x equal negative 1 is a solution. Now, do you remember what we do with this? This is the constant term. This is the term with x to the first. This is going to be the term with x to the second. So now we're going to take our quadratic, and we either use the quadratic formula, or we try to factor. Is this factorable?
yes.
Plus 3, minus 2. So x equals negative 3, x equals 2. So your solutions are x equals negative 3 and x equals 2. Notice, 2, negative 3, and they're my solutions. It was 3 of those 8 possible numbers. What else do I want to emphasize here? Make sure that you include the one that you found initially. Shall we do it again?
No.
I think we do need to. Yes.
How did you find 2?
How did I find what? Positive 2? Okay. Yeah, we're going to do another one. New one.
So if you get it squared, if it ends up being squared, you can just solve it and then you're done.
Right, right,
If it's a cube, you gotta keep going.
right. If it's a cube, you got to do more synthetic division. All right. So the first thing I'm going to look at is no sign change, one sign change, which means there's one positive real root. Oh, I'm sorry. How's that? All right. So I'm going to go ahead and get rid of this because it's blocking everything. So now what I'm going to do is I'm going to substitute in a negative x. You ready? G of negative x is going to be negative x cubed plus 7 times negative x squared plus 11 times negative x minus 3. This gives me negative x cubed plus 7x squared minus 11x minus 3. All right. There is 1, 2, so it has 2 or 0 negative real roots. So now we're going to do our P over Q deal. What's P? 3. And what's Q? So what are the factors of 3? 1 plus or minus
3.
over 1. What are my possible combos? 1 and 3. 1 over 1, 3 over 1. So now let's set up our synthetic division. We've got 1, we've got 7, we've got 11, and we've got negative 3. So do you want to start choosing positive numbers, or do you want to start choosing negative numbers? Okay, what negative number do you want to start with? Which one? Negative 1. I'm thinking, look at this, if there's 2, we only have 2 negatives. I don't think we can go wrong here. Oh my, good problem. Negative 1, are you making fun of me? Is 6. Uh-oh. Negative 6 is 5. Negative 5, no. That is a negative 8. I wonder if I wrote a bad problem. Oh, I might have written a bad problem. So it's 2 or 0, so let's try positive. Did I pick the same right ones? Did I pick it from G? Negative 3 works? One, negative 3, 4, negative 12, negative 1, 3, 0. So maybe I lied. All right, so let's see what we have. We've got x squared plus 4x minus 1 equals what? 0. There just went out the rule, Descartes' rule of signs. Negative, positive, negative, negative. 1 change, 2. Okay, I don't know why that failed. However, is that factorable? Seriously? Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is negative 4 plus or minus the square root of 16 plus 4 over 2 all over 2, which is negative 4 plus or minus the square root of 20 over 2, which is negative 4 plus or minus 2 square roots of 5 over 2, which is the same thing as negative 2 plus or minus square root of 5. So, you see, I have negative 2 minus the square root of 5, which is, by the way, negative. There's the second root. And I've got negative 2 plus the square root of 5, and that's bigger than 2. That's the positive root. And then I have x equals negative 3. Wow. What does this tell you might need to do tonight? I was thinking maybe like quadratic formula. Drink some apple juice,
Yeah, that's not gonna help.
Amanda said.